This conference will now be recorded.
Welcome back to day 5 of SCADA ICS Hacking and Security from Hackers Arise. I'm OTW, and this is our 5th day of this class. It was originally scheduled to be a 5-day class, and it has been in the past, but I have been suffering from COVID and the remnants of COVID, the after effects, and one of the after effects for me is my voice, and still kind of a little bit rough. But I think I can get through today's class and tomorrow's class. So we're going to do another day tomorrow. We're going to limit to spare my today's class to 3 hours, and we'll come back and do 3 hours tomorrow, and we should be able to cover all of the material. So it's going to be a 6-day class. All right. So I want to thank you all for hanging in there and continuing to come back. I know it hasn't been easy, and I know it hasn't been convenient for people, and I apologize for that. But if I could have avoided COVID, I would have avoided COVID, because it's, you know, I'm vaccinated and I'm boosted, and it was not fun. It had me down for, I don't know, 5 days or something like that. Yeah, this is one virus that's hard to beat, and I think I want to just kind of caution everybody that, we're kind of, thinking we're past COVID, and I think this could be a rough winter, right? Because everybody's kind of let down their guard. People aren't wearing masks anymore. The airplanes aren't requiring masks anymore. Airlines are not. Schools are not. And it's still out there. It didn't kill me, right? But it wasn't fun, right? So just kind of keep that in mind, that it's still running around out there, and I don't think I have any permanent damage from it. We'll see about my voice. My voice is the only thing that's still a little bit damaged, or as a residual effect of it. I don't show any signs of long COVID or anything like that. But just kind of keep in mind that we're not past this pandemic, and it may not kill you, but it's certainly not fun to go through. Right? It's yeah, let's leave it at that. Okay, let's get back. Well, we left off, right? We were looking at Modbus CLI, right? We were doing some attacks on some Russian facilities. Let's go back there, right? Uh, and just take a look a little bit more at that. And I've got, let's see, do I have? Yeah, here it is. Okay. I think so far you guys haven't told me my voice has been lost yet. So let me know about that. But I think we got a pretty good internet connection today, but maybe I'm wrong. We'll see. Okay, administrator. Okay, you were really good at finding us some good targets in Russia. Do you still have some for us, or do you want me to go pick out some? You've been, here's one right here that comes back from the other day. I was just kind of going up arrowing. I haven't rebooted the system since we were in class. Let's just quickly try this one again. Okay, so that's a right. Yeah, Chris asked, do I have that script? I don't, and I'm hoping that he's here, whoever it was that gave me that little for while script. Okay, it's control. Good, thank you, control. And we'll try that. All right, that's one of the things I wanted to do today. This was on slave number 3 at this IP address. Let's just see if we can. The funny thing is that we were doing this a week ago, and it looks like nobody's paying any attention, because we were once again able to write to that same IP address. Yeah. Okay, so here's the values that we put in, and there's the values that they have in there. Okay. One of the things that we looked at earlier was we looked at some PCAPs, right, of our our attacks, of some attacks, right? And some of them was just reconnaissance. Let's go ahead while we're here and let's open up Wireshark. Let's open up. All right, let's go open up Wireshark. Okay, Control's got a little script there for us. We'll give that a shot, see how it works. Okay. And here's open up Wireshark. I'm gonna tell it to sniff on ETH0. Okay. And before, excuse me, before we go any further, let's go ahead and try running this command again. And that's just a read. So let's go to our Wireshark and see whether or not we can find those packets. There it is right there. All right. And apply as a filter. Administrator, come on back. Control, we'll get to your script in just a moment here, but I want to take a look. Okay, you can see here, here's the packet. All right. Okay, transaction identifier, unit identifier. Remember that over here, we looked at slave ID 3, right? So let's see what it looks like in Wireshark. It comes up as unit identifier 3, that's slave 3, right? The protocol identifier is always going to be 0, okay? And then if we go down here and look at the Modbus, right? All right, here we go. Function code read holding registers. Okay, that's what we were doing. That last command was reading the holding registers. Okay, and then the word count is 20. All right, let's try some others. Sound problems? Okay, good. I'm glad you're here, administrator. Good, good, good. All right. So what we're doing right now is just kind of doing a Wireshark analysis of these commands that we're sending into this Russian system. All right, let's go ahead and try let's up arrow, and this is our right, right? And let's go ahead and try that. All right, and then let's go in here. So if you are, what we're trying to do here is that I'm trying to show you what these attacks look like from a security administrator's perspective, right? So if you're on the end of being attacked, okay, then this is what it's going to look like. Let's go ahead and just filter out everything but Modbus. Okay. And so here's what we just sent, I believe. This is the packet. Let's take a look at it. Okay. And we can see the unit identifier is still 3. Okay, that's the slave ID. And then write multiple registers, all right? So we're writing to those multiple registers, and you can see there's our values, right, that we have sent out. Let's try changing it slightly to see what it looks like, and let's try writing to slave number 2 instead of slave number 1. Okay. Okay, that seems to have worked. Let's go back to our Wireshark. And we got some more traffic here. Let's go here. And you can see there's slave identifier 2. This is what, if you're working on the security end, this is what it's going to look like, okay, when somebody's out there trying to mess with your system, all right? I don't know what this is here. This 11:30 right here. We didn't send that. This seems unusual here. 11:30 and then a 1 and register 9. Let's take a look then. We can continue to attack these Russians, and that's always fun to do. But I want you to be able to, we got to think about security here too. So we got two sides of the coin, right? This is SCADA hacking and security. So, some of us, some of you are going to be involved in securing these sites, and we've seen that in many cases, there's nobody securing or devices securing these SCADA sites in Russia. Some of them, there is some security, and the same applies for the West as well. It's not just the Russians, right? This is there's just really very little going on in terms of security. I guess administrator has another one for us. All right, let's try that one. We're going to do let's see if we can 10. This is going to be a read operation from slave 2 at another IP address. I presume it's in Russia. Do you have any information what town it's in or what it is, what the facility is doing? And this would be on slave 2. Okay, you'll check. Good, thank you. And we're going to go and read the registers. Okay, there we go. All of them are zeros except for the first one is 250. All right, let's go see what that looks like in Wireshark. Okay. We filtered just for Modbus, so we filtered out all the other traffic that's going across there. And looks like this, let's see, it's the last one. Is this it right here? Looks like it is. All right, slave number 2, function code write multiple registers, word count 10, byte count 20. Now that's the previous one. Let's go down. Let's cancel somehow. That's, okay, there we go. I have to just move down a bit here. Okay, here's here's our attack here. Unit identifier, reading holding registers. That's code 3. All right. And of course, because we're reading, it's not showing us any data. Let's go to the next one, the response. All right. We read the response. We should see the responses. There we are. There's the responses, and so it goes out, and we ask for 10 registers, right? And it comes back, and it gives us 20, right? Probably because those registers, as we've specified it, we're asking for a single byte, and these registers are 2 bytes. Okay, they're 16 bits, so it's giving us, for each one of them, it's giving us 2 registers. The administrator's got another IP address for us. Do you have any information on it before we go and try to hit it? It's somewhere in Beluzerski. I'm sure I didn't pronounce that correct. Beluzerski. All right. I guess the pronunciation's not that important. All right, let's go back. But you don't know what it does. Okay, you don't know what kind of facility it is. All right, let's go ahead and see if we can read from it. Yep, it's down somewhere in Russia. Yeah, okay. How you pronounce it is not that important. There, we got some good data coming out of this one. This is just a reading on slave 2. Let's try slave 1. Slave 1 reads really well too, though the data looks exactly the same. Okay, let's try slave 3. They all look identical. Let's try writing to them. And, oh, let's just put 1s in. Let's just mess with these guys, change their values. So we've got 10. You can see here the numbering of the registers. These are obviously 2-bit registers. I mean 2-byte registers. Right, so we've asked them for 10, and we're getting MD0, then MD2 would be the next register, then MD4. Yep. And we're just going to see if we can't mess with them and put in some 1s instead of, it worked. All right, let's go ahead and do a read now. Don't you love it when we mess with? Didn't write. Okay. So we're reading, but the write operation, usually if the write operation fails, the tool will crap out. Okay, let's take a look at what, okay, let's see, administrators, by the way, I've had several controllers down this week. You mean you've knocked out several controllers in Russia? Is that what you're saying? Yeah, okay, good job. All right, let's keep it up. It's gonna continue to be a wrench into the operations, into the industrial operations of Russia. In many cases, by doing this, things aren't going to blow up. Okay, they're not going to necessarily shut down, but if you can turn off a controller or change the values in a controller, things are not going to run smoothly. They might blow up, but most likely the operation is just going to like, what the hell's going on here? And by continuing to do this, we can continue to make life difficult in the industrial sector of Russia and take resources away from their war machine, take resources away from their cybersecurity operations. Because remember, if they suspect that we are attacking their industrial sector, that means they're going to take resources onto that away from other places to take and try to protect their industrial resources. Right? So, like any country, you can't conduct war if you don't have your industry working. It's very hard to do. Okay. Administrator says Russians also have Siemens controllers. I wonder if we covered some at this protocol, this course. Right now, we can only, we have still a lot to cover. So yes, there are a lot of Siemens controllers in Russia. Siemens controllers are the ones that were used in Iran. Siemens accounts for 30 to 40% of all of the controllers in the world. But here we're just focusing on Modbus. We'll deal with some of the other protocols and controllers in the advanced course. Let's go ahead and continue to see if we can't write to this particular IP address. And let's try reading. Now, it's not going to let us to, okay, for sure. Advanced SCADA, yeah. Let's try it. Control wrote that little short little script. Okay, that's just like a for while loop. Okay, let's give that a shot and see what we can do with it. Let me see if I can copy and paste it. All right, here it is. Got it out of the chat. Just copying it. Going to put it into Kali and paste. All right, we can change the IP address though. Let's change the IP address to. Now let's use the one. That one. That one we know we can write to. Okay. And let's go ahead and give it a shot. So this is what this is going to do. Is it for I? Okay. In. So we're going to go through each one of the slaves, right? I through 1 through 254. All right. Do Modbus write slave, and then he's using the variable. All right. So it's going to go through each one of the slaves at this IP address, and then try to write this data, and then after it goes through 254, it'll stop. Let's see what we can do. I'm going to hit enter. Whoop. I hit enter at the wrong place. There we go. Here it goes. We're going to try to do all 255 slaves. If it hits the only problem with this tool is that if it hits a slave that it can't work with, yeah, the whole tool will crap out. You can see the packets running through over here, right? You see them? Okay. Administrator's got us another, and you can write to this one. Okay. Let's see what we do with this one. See, this is what happens, all right? But the thing is that it craps out, okay, when it hits a slave it can't write to. Okay, rescue and open TC timed out attempting to create connection. All right, we may have created a DOS condition there. Let's see. Modbus timeout. It's still running. Then we'll use the same for while loop to read those and see what we can get. See how many of the slaves that we are actually able to write to. It craps out, each one of these is a new command. So you know, it craps out, sends a new command, craps out, okay. Nephos has a suggestion there to background our little script. I'm going to stop it, all right, and see what we've come up with. All right, Control C. See if we can take control of the system again. It still wants to keep running. Controls. There we go. Okay, so let's alter our script, and instead of writing, we'll read. Okay. Yep, all of those are possible, but we're just going to keep it simple. Okay, you can add some error handling, and put in a delay, put a little sleep command in there. All right, but let's go back and see if we can now read and let's change our script just slightly. Okay, and see if we've been effective at changing the values on this system. You know, if we have, we've done some serious damage to this particular plant. Let's go ahead and run this. Okay, there's the first one. Here we go. Ah, but it looks like we're not changing the values here. These are all the, oh no, we are. I'm sorry, here they are right here. Yep, here they are. Yep, those are the values that we're changing. Yep, all right. These are the ones that were already in there. We've got quite a few of them. Look at this, look at all the slaves that we've hit. And it's still running. Let's take a look at our Wireshark while it's running. Query response, query response. Okay. Let's go take a look at one of them. Unit identifier 79. So we've gone up quite a ways. Okay, let's take a look at this one. Unit identifier 89. So we've got about a third of them done. Reading holding registers, function code 3. These guys are going to know that we've been there. The amazing thing is that, you know, even with all of this traffic, we're not getting any firewall or any type of protection being thrown up to stop us. If anybody's paying attention, they see this. If anybody's paying attention, the key is that nobody's paying attention. Let's see where we're at. We're up to function unit identifier 155. And let's look at our results and see if we're still getting positive results of changing values. Looks like we are. Yeah, no one's paying attention as they should have set alarm bells ringing for sure. Yeah, I mean, if all of a sudden somebody's sending Modbus commands through your port 502, who's outside of Russia, then you know you should be scrambling to block this right away. Yeah, it works. This is I'm not sure we're DOSing it yet. Okay, as long as it's reading and writing, it's not a DOS condition yet. Okay. Yeah, what I might do is to see if you DOS the port 502, what you're going to do is you're going to keep the administrator from being able to control the system. Right. So what you could do, administrator, is to do something like what we've just done and change all the values. Right, exactly. A function code 8 subcode 4, right? You could do it just finished up. Okay. So, but what you could do is change the values inside of the PLC like we're doing here, and then DOS port 502. And what that means is that the administrator would not be able to come in and be able to fix the situation, right? So you've blocked them from being able to connect to their own system and fix it after you've gone ahead and done this, right? So then it would require somebody who's actually on site. It would require somebody who's actually physically on site to be able to fix it. And once again, it might be possible for them to fix it, but what you're doing is you're just, you're using up resources that keep a smooth operation of their industry from proceeding, right? Whatever this particular facility happened to be. All right, so effective little script. Thank you, Control, for that. That was excellent. Worked smoothly. All right, let's just throw it up on the screen again so you can see it. All right, it's a pretty simple script. Just a for do loop. Right, just going to go through all 254 um, uh, slave IDs. And in this case, it's reading them, but earlier we were writing them. Let's mess with these guys some more, just for the just because we want to. All right, let's one of the things that you notice here is that we're using MD, which is double word, okay? And let's try using the MW, okay, just the word, and putting in just some random values. And we're gonna write to each of the slaves, yeah, all right. And let's go ahead and run that. Let's go back to our Wireshark, and let's take a look at that. Writing multiple registers, okay, function code 16, right? Let's see, this is transaction identifier, unit identifier 8, okay. Let's go here and look. Things look like they're working for us, okay. Function code 16. We could do a lot of damage with a simple script like this. We're up to unit identifier 68. But yeah, after we've changed all the values on this particular plant, right, or changed some of the values, okay, things are not going to run the way they should. We don't really know exactly what we've changed, but it's not optimal, right? These types of systems, are carefully choreographed to make sure all the pieces work together, right? And this obviously is going to change the values inside the PLCs, meaning that things are not going to open and close properly, right time, right pressure, whatever that value happens to hold, and the system is going to go awry. I'm going to stop this and just do a quick read then of our system. Also, I want to go ahead before we move on. I'd like to try to do the let's do the not the slaves, but rather the coils, and see if we can't open and close the coils. User says, if Modbus is master slave, could touch the master, therefore affecting all the slaves? Okay, so Yeah, I'm thinking about the answer to your question. If Modbus's master slave could touch the master, therefore affecting all the slaves, I'm not sure. Okay, I'm not sure. Yeah, I think not too. But you can, yeah, Voltage says you can do it from the GUI. So if you get into the HMI, right? Remember, if you get into the HMI, game over, right? And that's part of what Voltage was showing us and what we were doing in one of the first days is that we were looking at some of the HMI, and to them we found out that many of them didn't have any type of lockout on password cracking. So if you can crack the password on an HMI or otherwise get into the HMI, okay, then you can do anything you want, right? You've got control. The HMI is designed for the engineer to be able to monitor and manage the system, okay? So you basically have all the control of the system. Now, this at HMI, yeah, HMI is the real deal because basically it's like getting root access to a system, right? Once you have the HMI, you've got the GUI that they're using, and you can go ahead and change any values whatsoever. Getting the HMI, the easiest way to get the HMI, of course, is to be able to get the credentials of the HMI. There's other ways of getting HMI. Basically the HMI is just software, right? It's just like any other application software, so it can be broken. Okay, and there's a number of exploits in exploit DB and other places, Metasploit, that will do that, but they're very specific to the HMI, very specific to the HMI. Let's go ahead and run this again. Woohoo, look at that. Okay, now let's go and DOS this guy. And he'll never be able to change these values. Yeah, HMI is the real deal. That's when you have total control over it. Okay, when this is done running, we'll go ahead and see if we can't values that are being held in the register. So I was just mentioning that what we're messing with, okay, are the values in the registers that control things like at what pressure do I open the valve, what pressure do I close the valve, okay, how long do I keep the valve open, how long do I run the motor, these type of things. That's what these values are. We're still getting reading through the values that we've changed. Looks like we've changed the first 10 registers of of each one of these slaves. I'm going to go ahead and stop it. Yeah, let's do Control C. And let's try and see if we can't change the coils on the same system. Yes, exactly. And this is just, you know, the thing I learned from last week's session is I only changed with the integer registers. There's 3 more, right? There's floating point and there's double word, right? So there are 3 more registers. There are 3 registers. There's integer, floating point, and double word. All right, system, it's just kind of still doing its thing. You've updated your tax scripts after that, good. Once again, you know, these are finely tuned systems. So sometimes changing any value in them is going to make the system not run suboptimally. Suboptimally can mean that it's not turning out the product as it should, or it's turning out a defective product, or it's not working at all. Right? It may blow up, depends upon the nature of what the facility is building and what slave you're impacting. But I can assure you that, you know, you're doing some damage if you're changing values to these PLCs. Okay, got it again. All right, let's try and do the same thing, but this case, let's do it to the coils, right? And let's just use M0, all right? And I'm gonna up arrow. Let's go to the right and go M0, which is the coils. These are just Boolean values of open or closed. And let's just, let's read them first and see what's in there. All right, so let's read, and let's read the first 10 and see what values are in there, and then we'll change them. All zeros, okay? Yeah, let's turn them on. That's what we're gonna do next. We're gonna put in all ones, okay? So all of these coils are closed. Or they're off. So we're gonna go ahead and change them to open, okay, or on. I'm gonna go ahead and stop it. It looks like we know what the values are. It looks like they're all closed. So let's go ahead and stop it. All right, and let's change, and let's see if we can't write. Okay, we're gonna change the values to just all open. Right. Good. We got 10 of them there. That's good enough. All right, let's go, and we're going to write. And let's see if I got everything set correctly. Write to slave, yeah, that IP address. These are the coils, the on-off switches. Let's let it fly. Nothing has crapped out yet, so that's a good sign. Let's take a look at Wireshark. Okay, write multiple coils. You can see it right here. Function code 15. We're at unit identifier 22, and we've gone farther than that. All right, this is going through. We're writing the coils. Looks like we're being successful. Let's let it run a little bit more, and then we'll go ahead and read the values and see if we've actually changed them. I don't know which one this is. Earlier we had, it was an electronic manufacturing facility. Administrators kind of picking these out in Russia. I don't know what this is. If you know, you can go on to Shodan and check it out and get an idea of what it is. All right, I'm going to go ahead and stop this and then go do some reading and see if we've actually changed the values on this. Usually if you can change the registers, you can change the coils. All right. So on secure facilities, you'll see that you can't write anything at all. But if you can write, you can usually write to all of the registers and all of the coils. Anybody figure out what kind of facility this is yet? Just put that IP address into Shodan and take a look at it. Okay. Administrator says, I have in my database, but most of the targets are situated in cities and are difficult to find out what exactly we are attacking. Is there a port 80 open, maybe a web server that'll tell us a little bit about who they are? Like, let's go ahead and there are many. Okay, let's go ahead and let's just run a quick Nmap scan. It has SQL, UN has SQL, and it has RDP open as well. Yes. So what these guys are doing, those of you who aren't doing it, and I'm just kind of recounting, you're not in class and you're watching the video, is they're simply running a Nmap scan on it, and or maybe you're even looking at it through Shodan, but we'll just run a quick scan on it. It's going to create a lot of traffic. I got a lot of traffic running here. 5698. And hit enter. Looks like some of these are failing over here. When you say you have administrator, you're working in, I presume, in Kharkiv, in Ukraine. Okay, here's what we have coming back. Okay, as Robin was, Christopher was saying, there's MySQL running there. There's a VNC running there. Wow. There's Telnet, SSH, FTP, but there's no port 502 because it's not on the list of the. Well, maybe not ancient. You'd be surprised, Christopher, how many people still have a Telnet running on it. Let's go see if it has port. It should have port 502 because obviously we've been hitting port 502. Yeah, it's coming back and telling it's filtered though. 502. This one is a honeypot. Oh, damn. Windows Server 2012. That's unfortunate. Let's go ahead and do our read operation. Okay. On that same system. See, we've changed the values. Administrator, give me the IP address. Okay. You mentioned earlier, you're suggesting we use another one. Yeah, this looks very suspicious when we do an Nmap scan on it that has Telnet and SSH on it. Okay. Thank you. I'll try that one. But I'm always surprised when I see a system that still has telnet functioning on it. It is out there. Okay, administrators give me a couple more IP addresses in Russia to try. We'll try those out. But when you do an Nmap scan on it, it looks very suspicious. What happens when you go to port 80 and you hit port 80? What's the server say? Come on, trying to stop this, my script. Come on. That IP has home assistance login page on port 8123. Yeah, it has 3389 open right there, which makes it vulnerable to lots of things. Okay, the IP is labeled as a honeypot and show it. Just kind of a heads up is that Shodan isn't always right about labeling things honeypots, but this one looks like a honeypot to me. Okay, so yes, it probably is a honeypot, but Shodan isn't always accurate. I mean, they have they have an algorithm that kind of says if it has certain attributes, then it's probably a honeypot. Let's go ahead and try another IP address in Russia. Let's put in, let's do a right. And let's see, let's try the 31 address. 31. Let's figure out what it is before we attack it. Let's do a little reconnaissance, guys. Come back to me and tell me what it is. Yeah, I'm gonna go ahead and just run an Nmap scan on it and see what it is. At least what ports it has open. 30. The Russians are going, what the hell? Okay, 502 is filtered. Let's try the others. It's taking a long time to return. I'm drinking lots of water. That it also means I have to pee a lot. Come on. Let's see. 22 seconds remaining. You're 76% done. Okay, here we go. So we do have, this one says has telnet as well. Okay. Okay. SSH, HTTP, HTTPS. It has VNC. Let's go ahead and take a look at it. All right, let's see if we can write to it. Yeah, the fact that it has both telnet and SSH and VNC makes me concerned that it's a honeypot as well, but let's go ahead and see what we can do with it. Let's look at Wireshark and see what's going on. Write multiple coils. Okay. You can see here that multiple coils is 15. Unit identifier 28. Let's try another one. We're up to unit identifier 62, right coils. I'm going to stop it and take a look and see if we've done any damage. All right. So we want to read, okay. Let's see, let's get the IP address. Let's copy. Let's read those coils. See if we've done any damage in changing them. Okay, so we're Modbus read, slave. Okay, these are the coils. We're going to read 10 at each slave. All right. We should be putting in ones. Well, you can see that we effectively are putting ones into some of the coils. Remember, they were all zeros before, but not all of them. It may be that some of the coils are non-functional, so we might not be able to write to them. Okay, there's a little crap out. But in any case, we're able to, the ones that are functioning, looks like we're able to change their values. Probably about half of them, it looks like. Yeah, administrator says, yeah, what happens? I don't know why. I'm not entirely certain either, but you can imagine a case where all of the coils are not functional, right? I mean, they're all showing initially as being closed. And if a coil is not functioning, can't open and close, it's always going to throw a 0. Yuri says, is it possible to block some of values? I'm not sure what you're asking me. In other words, to go in there and say some values should never go into there? To say, okay, this particular register can never have this value. Is that what you're asking me? And the answer is, I don't think so. Okay, I don't know of a way of doing that. I could, imagine maybe I've got some ways to do that, but top of my head, I don't know of a way of doing that, if that's what your question is. Okay, I've got 11 minutes after the hour. Says, like if the operator on module says those values M5, M6, M7 are not changing whatsoever, it's a possibility. Okay, all things are possible, right? So if I put in my code that those values never change, that's a possibility if it's written into the code. Okay, so we have that ladder logic that's controlling the PLCs, and it's possible that they could put in the code that this is a static value, it never changes. Okay, and Voltage has some comments there as well. It says it depends on the device the PLC is connected to. Stepper motors require different coils than single phase motors, which are different from large electrical relays. Some values will never change because they're not used. That's my point, exactly, as Voltage points out there. Some values will never change because they're not used. If they're not part of the system, no matter, if you're sending values in and they're not part of the system, they're not going to change. Let's go ahead and take a 15-minute break, give my voice a little bit of break, and you guys can run to the bathroom and get yourself coffee or whatever you need. And we'll come back at 27 minutes after the hour. See you then.
This conference will now be recorded.
Okay, we're back. And hopefully everybody had adequate time to do what they needed to do. And let's go back and log in, and we can see that we're able to change some of the values. Some of the coils may not be functional, or they may be set to a static value and they're not going to change. But in any case, we're able to change about half the values on those slaves, and that's not going to be good for them. All right, we have changed the values from open to close or close to open, and we don't know exactly what that's going to create, but we know it's not good. All right, we've run into some honeypots, and hey, can you guys hear me? Peter says the audio went out. It's back. Okay. So it just went out for a moment there. So what we're going to do is we're going to address the honeypot issue. Now, there's a honeypot on Hackers Arise under SCADA hacking. It's a SCADA honeypot, and that's what we're going to be doing now. So that if you want to practice these skills, but you don't feel comfortable going ahead and doing them in the real world, okay, in the wild, as people say, we have a honeypot for you. And I will give you, I put it up on Dropbox, and you will be able to download it. It's a pretty big honeypot. It's under here. I have got it here under Ubuntu. I gotta remember what the password is for this thing. Yeah, I got it right. Look at that. All right. So I've built this honeypot, and I will give you access to it so you can mess with it. Let's go ahead and this is actually the con pot. You may be familiar, if you're familiar with honeypots in the SCADA ICS arena, this is probably the most popular honeypot. As a matter of fact, let's go ahead and let's go open up Shodan. For, that's both good and bad. That's the most popular. And I'll put Shodan up up here, and let's go port 502. And let's see if we can find some honeypots here. Let's look in Russia in particular. Let's keep our focus on Russia. There's RU. Okay, see the tags right here? ICS, ICS. What was the IP address of that one that we determined was a honeypot? Here's one right here. Okay. So it's tagged as a honeypot. Now, like I said, these are not always accurate as they're honeypots, but the one that we're working with is probably the most common honeypot out there. Okay, looks like it's got 135, 443, 445, 502, 3389. You know, to me that's like that's a big red flag that says it's a honeypot, right? This might be the one we were working with earlier, right? There's kind of a rule of thumb of honeypots is that if it's really, really easy to attack, it's probably a honeypot. Here's remote desktop open on it. So the honeypot that I'm going to show you here in just a moment is the con-pot. It's not as obvious as this one is, right? But it's been used quite a bit. So as a result, people identify it as a honeypot. One of the things that it does do to try to keep from being identified as a honeypot is it uses different MAC addresses for its network interface card. I mean, one of the ways that you can identify a honeypot is that they all have, essentially the same MAC address. And so this changes the MAC address. And if you want to build it yourself, I have the instructions on Hackers Arise. We're not going to build it here. I've already got it built for you, and we're going to try testing it. So what we're going to do, we're going to primarily use it as a way to you to hone your skills in using some of these tools. So let's go ahead and start it over here. Let's go sudo conpot. Actually, we need the IP address first, right? So let's go ifconfig. We can't test it without knowing the IP. Let's see what it is. Well, they just use if over at Ubuntu. Ubuntu has IPA. Thank you. I don't use the IP, but okay. All right, let's see. We've got IP-A. What's our IP address here? 127. Here's our interface right here, ENS33. And there's our IP address right there. Okay. So let's go ahead and start our honeypot. It's going to be sudo conpot. Like I said, it's on. I have it up on Dropbox, and I'll give you access to it. You can go ahead and use it to test your skills. And you can use it as a honeypot. If you're, one of the things that we have to address, okay, comes back and says cannot start compot with root. Okay, my bad. It's a good idea. Let's start it without root. Huh, it's crapping out on me. Let's see what it says here. Cannot read Wireshark manufacturer's database. Well, that's not good. I had it running just the other day. Let's try compot-h. It doesn't even want to give me a help screen. Cannot read Wireshark's manufacturer database. Template. Let's try it again. No file, no such file or directory. Let me see what I have going on here. I might have another system that's maybe an older system. Let's go to virtual machines. And this one is Ubuntu 64-bit. Here I've got Ubuntu here. Let's try this one. I built these and that may be the wrong one. Oh, that's Dragon OS, that one. All right, well, we'll pass on this for the moment since this one's not working. I'll find out and get you the right one up there for tomorrow's class. One of the things that we need to think about, okay, is how to protect these systems. Right? So we largely focus on attacking them, and we have, a few hours left of how to go ahead and protect them. So let's talk a little bit about that. We've seen that some of these systems are most of these systems, I would say, I can say unequivocally that most systems are inadequately protected. Not always as as poorly protected as ones we've been looking at, but almost always are inadequately protected. So one of the things that we need to do, okay, as a security engineer in a SCADA environment is to properly segregate the SCADA systems from the business network, okay? So let's talk about that next. All right, let's go through and discuss ways that we can segregate the system so that if the business network gets attacked, okay, and is compromised, that the attacker can't get into the SCADA network. Once again, this is what happens in probably most of the cases of attacks against SCADA systems, and certainly was the case when the Ukraine electrical grid was attacked in 2014. They first got into the business network and then moved from the business network to the SCADA network. I'm gonna go ahead and close this down. Let's go to our network architecture. Let's take a look at how we can go ahead and protect these systems. Control says hire a Russian admin with a different date of birth, right? Well, I mean, there's some simple things that you can do oftentimes aren't implemented. Simple things that we take for granted in securing, traditional IT systems, like, use complex passwords. Don't use your birth date, okay? Or somebody's name in your family. So oftentimes those are ignored because SCADA has been ignored for, during this last 20 years or so, when cybersecurity has grown in importance. 20 years ago, nobody paid any attention to cybersecurity. It just was, there was still attacks taking place, there was hacks taking place, but it just wasn't emphasized, and everybody was kind of poo-pooing it and saying it wasn't that important. Okay? In about 10 years ago, it became important. People began to pay attention. Microsoft started to pay attention, okay? But during that time, most of the focus was on traditional IT systems. The SCADA ICS systems were, they were still living on security by obscurity, all right? Nefo says he's got an issue that I may have forgotten to put in the -F, okay? Let's see, that may be exactly what I did wrong. Let's go and boot it up and see if that's what I forgot to do. Where is my? Did I close down all of my virtual machines? I may have. I think I did. Let's go ahead and start it up again. Yeah, I was pretty sure that that thing worked because I had tested it just a few days ago. So I may have just run the command incorrectly. I think you're right. Then we'll go back to the network segregation after if this works. And this is, I think this is exactly the copy that I put up on Dropbox. So hopefully that's the issue. Otherwise, I'm going to have to fix it and then put a new one up. Notice that this is an older version of Ubuntu. I found that the Conpot doesn't work without a lot of alterations in the current versions of Ubuntu. Just kind of give you a heads up on that. Let's open up a terminal. All right, let's go Conpot -f -- template and the default template. Looks like that may have solved it. Nope, it still doesn't. It still craps out. Conpot -f template default. Okay, well I'll work on this for tomorrow's class. Let's go back to our network architecture. And so what I was trying to say is that people hadn't paid it much attention, and it's only been in recent years that we've begun to see some attempts to be able to secure these systems. And just our work in this class and attacking the Russian systems tells you that's typical. And I would say that, believe it or not, that the Russian systems are more secure than the systems in the West. All right. So I've been working on these systems for about 10 years, maybe a little longer, and I've watched the Russians begin to make their systems more secure. But at the same time, I haven't seen the same thing take place in the Western systems. I see a lot of systems that are easily hackable in the West. Anyways, let's talk about if it was your job, okay, and hopefully maybe at some point it is your job to be able to secure these systems. Let's talk about how you can go ahead and do that. How are you going to structure, okay, the network to keep them more secure? Okay, start with firewalls. Okay, network firewalls are devices, you guys all know this, or systems that control the flow of network traffic between the networks employing differing security postures. In most modern applications, firewalls and firewall environments are discussed in the context of internet connectivity and TCP/IP protocol suite. Let's point out right now the simple fact, right, that we were able to send in Modbus commands into these Russian systems. How could a security engineer have stopped us? Well, it's pretty simple, right? All they need to do was to put a firewall up there on that system and block all the IP addresses except for certain IP addresses that their administrators needed to use. So we have administrators, they have the static IPs, we put the static IPs in there, we block all the IP addresses except those static IPs, and voila, nobody else has access to it. And even simpler is, you could block IPs from outside of Russia, which I'm kind of surprised we haven't seen that, right? That's relatively simple to do. In any case, so firewall will be the first step. Put a firewall up there between port 502, blocking everything except for the IP addresses of the administrators. Simple, straightforward. It's going to do, it's going to keep us from doing what we just did, right? However, firewalls have applicability in network environments that do not include or require internet connectivity, such as between networks, okay? For example, many corporate networks employ firewalls to restrict connectivity to and from the internal networks servicing more sensitive functions, such as accounting or human resources, or the SCADA network. By employing firewalls to control connectivity to these areas, an organization can prevent unauthorized access to the respective systems and resources within their more sensitive areas. This is kind of standard, security that we all have hopefully learned, and it isn't often applied to SCADA. Administrator says, if geo blocks are easy to overcome too, for example, via proxy chains or Russian proxies. Yeah. Administrator is saying that basically if you go ahead and block by geography, and that's easy to overcome by using proxies, proxy chains, VPN. But I'm thinking of it more as a whitelist of saying these are the only IP address, okay, that are allowed to enter and come through port 502. Michael McBride says, got to use a land whitelist or something. Yeah, I mean, maybe not land. I mean, if you even if you have an administrator who's remote, and most of these administrators are, right? Then all you have to do is block all IP addresses, except say these 3 IP addresses or this 1 IP address. All right. If you go back to the system that I hacked in 2016, the Schneider Electric system, the application itself, which was a building automation system, actually had a whitelist built into the application. So Schneider has a whitelist utility built into the application, but nobody was using it, right? So yes, I mean, you could put a firewall in, you could put a whitelist in the firewall, great. But in this case, it was actually part of the application and nobody was using it. So all the IP addresses were allowed, all IP addresses were allowed to log in or attempt to log in, okay? And so it's something simple like a whitelist can do a lot in keeping, for instance, the attacks that we just implemented out of these systems, right? It can apply to HMIs as well, right? If you say only this IP address can access this HMI. Administrator says you have to have you can have all the tools, but without brains, it's useless. Yeah. Well, and sometimes it's not brains, sometimes it's neglect. Okay, you have somebody who's who isn't really familiar with the application, and they're told to put it in place, and they didn't read the 400-page manual, right? And they're not thinking about security because the boss said, get this running by tomorrow. And then after you're done with that, do this, right? And this is often the case in our industry. We're all tend to be overworked. We're trying to do 1,000 different things. And so, there's not necessarily the attention to detail and to security that should be there. So I'm not necessarily, condemning the person who put those in place. I'm just saying that sometimes security is not the first priority, and you have people who are implementing things that just don't have the skills and the knowledge, right? In an ICS environment, firewalls are most often deployed between the ICS network and the corporate network. Properly configured, they can greatly restrict undesired access to and from the control system, host computers, and controllers. All right. So all these are systems that sit within the business network, okay, the corporate network, we can restrict access between those to the SCADA network, thereby improving security. They can also potentially improve a control network's responsiveness by removing non-essential traffic from the network. So it's going to be more responsive the less traffic is traveling across the control network. That'll make the whole system run better. When properly designed, configured, and maintained, dedicated hardware firewalls can contribute significantly to increase the security of today's ICS environments. Firewalls provide several tools to enforce a security policy that cannot be accomplished locally on the current set of process control devices available in the market, okay? Because they don't have any authentication, right? They don't have encryption, including the ability to block all communication with the exception of specifically enabled communication between devices on the unprotected LAN and the protected ICS networks. Okay. Blocking is based on source and destination. That's what we're talking about here as far as whitelist goes. Blocking based upon source and destination IP addresses, pairs, services, and ports. Blocking can occur on both inbound and outbound packets, which is helpful in limiting high-risk communication such as email. On many of these systems, like we were just working with, you'll see that we can go ahead and read, okay, but we can't write, right? So that there is a firewall in place that's actually keeping out this blocking. My voice is going. That's blocking us from being able to send commands that the commands that will actually write. More water. Firewalls can also ensure authentication of all users seeking to gain access to the ICS network. There is flexibility to employ varying protection levels, authentication methods, including simple passwords, complex passwords, multi-factor authentication, tokens, biometrics, and smart cards. In reality, you don't see almost none of that being used. Okay, oftentimes you'll see simple passwords employed, and that's about as far as they'll go. I mean, I think we were working with some HMIs that were in the U.S. Remember the Allen Bradley systems that were in I think they were in Wisconsin, and we were able to access the HMI and without, and we had to authenticate ourselves against them, but there was no lockout. So something as simple as a lockout, that something we all put into our local area networks, okay, or we put into our web servers, you're not going to find that often, okay? Sometimes you will on these SCADA systems. So basic common sense approaches to cybersecurity are often lacking in these systems. Select a particular method based upon the vulnerability of the ICS network to be protected rather than using the method that's available at the device level. Enforce destination authorization. Users can be restricted and allowed to reach only the nodes of the control network necessary for their jobs. This reduces the potential of users intentionally or accidentally gaining access to or control devices from which they are not authorized, but adds to the complexity of on-the-job training and cross-training employees. And that's oftentimes why they're not implemented, right? Is that it just adds complexity to the system, and there's usually very few people who are working in security in these installations. And in the case of the Russian systems we just came from, there's probably nobody working in security. Record the information flow. Okay, so one of the things we need to do is make sure that we're recording all the information flow across the network, analyze it in IDS. One of the challenges of working in SCADA security is that most of the IDSs are not built and cannot interpret the data that's sent over a Modbus network, or for that matter, a Profinet network or an OPC network, and that's a real problem. So we see that some of the IDS manufacturers have tried to implement some basic ability to intercept and read these kinds of packets, but it's still far from adequate. Firewalls also permit the ICS to implement operational policies appropriate to the ICS, but that might not be appropriate in an IT network, such as prohibition of less secure communications like email, and permitted use of easy to remember usernames and group passwords. They might be designed with documented and minimal connections that permit the ICS network to be severed from the corporate network in times of severe cyber incidents. Now, logically separated networks. So one of the keys to keeping these networks secure is to basically to segregate them, all right? So the ICS network should, at a minimum, be logically separated from the corporate network
on physically separate network devices. When enterprise connectivity is required, then there should be documented and minimal, single if possible, access. So that would be like the HMI. The HMI will be the only thing that is allowed to access the SCADA network. Between the ICS network and the corporate network, redundant and backup access points if present must be documented. One of the things that I have found is that when I go to do a security assessment of a SCADA environment, the first thing to do is to assess all of the access points into the SCADA network. And very often, the corporation doesn't know, all right? They don't know all the access points. And so they'll tell you, oh, there's only one. And then you'll go and do some searching around and you'll find out that this vendor and that vendor still have access to the SCADA network, meaning if they get hacked, then your SCADA network gets hacked. A stateful firewall between the ICS network and the corporate network should be configured to deny all traffic except that which is explicitly authorized. Firewall rules should be at a minimum provide destination filtering, right? Okay, filter on media access controls by MAC address. So if we're going ahead and working on a local area network, then it should be filtered by media access control MAC address. In addition to TCP and user datagram protocol, port filtering, ICMP type, code filtering. These are all possible with most firewalls, right? An acceptable approach to enabling communication between an ICS network and a corporate network is implement an intermediate DMZ network, and we'll look at this in a minute. The DMZ should be connected to the firewalls, such as the specific restricted communication may occur between only the corporate network and the DMZ, and the ICS network and the DMZ. The corporate network and the ICS network should not communicate directly with each other. ICS networks and corporate networks can be segregated to enhance cybersecurity using different architectures. Several possible architectures can be used to accomplish this. And this is an area of ongoing research by folks inside the SCADA ICS industry. And there's been a number of different models that we'll look at. A dual home computers can pass network traffic from one network to another. A computer without a proper security controls could pose additional threats. To prevent this, no system other than firewalls should be configured as dual home to span both the control and the corporate network. That kind of goes without saying, I think. All connections between the control network and the corporate network should be through the firewall. By introducing a simple two-port firewall between the corporate and control networks as shown in the next slide, significant security improvements can be achieved. Properly configured, a firewall significantly reduces the chance of successful external attack on the control network. So what we're focusing on here now is the possible attack going into the corporate network and then moving into the SCADA network. That's different than what we were doing earlier. What we were doing earlier is we were basically attacking from the outside, from the internet, right? So this doesn't apply to what we were doing. What should have been done in those particular facilities is to whitelist IPs. That would probably be the best approach to limiting access to those systems like what we just did. Simply whitelist IPs, and then, and if it's on a local area network, whitelist the MAC addresses, be it even more specific. But what we're talking about here now is trying to limit access from the business network, the corporate network, to the SCADA network, so that if the corporate network gets compromised, that the attacker can't get into the SCADA network or can't easily get into the SCADA network. Unfortunately, two issues still remain in this design. First, if a data historian resides on the corporate network, the firewall must allow the data historian to communicate with the control devices on the control network. A packet originating from a malicious or incorrectly configured host on the corporate network, appearing to be the data historian, would be forwarded to the individual PLCs and DCS. All right, so here's a simple configuration. Firewall between the corporate network and control network. So here's the outside world over here, all right? And essentially what we were doing is coming from the outside world and going directly into the control network, right here, with basically nothing in between, okay? So the concern here now is, we're assuming that the outside world can't do what we were just doing, and that they would then have to get into the corporate network to get access to the control network. So what we have here is a internet, WAN, here's a router, here's a firewall. Here's our data historian, basically a database, right? That's being able to log all the information that's going on the network, an application server, a printer, some workstations, okay? And then there's a firewall between the corporate network and the control network, and this firewall might be blocking by MAC address, by IP address, what have you, to make sure that if this network here gets compromised, that they can't make their way into the control network. Network segregation. If the data historian resides on the control network, let's back up. Here's the data historian on the corporate network, all right? If the data historian resides in the control network, a firewall rule must exist that allows all hosts from the enterprise to communicate with the historian. Typically, this communication occurs in the application layer as SQL or HTTP. Flaws in the historian's application layer code could result in a compromised historian. Once the historian is compromised, the remaining nodes of the control network are all vulnerable to a worm, propagating, or interactive attack. Another issue with having a simple firewall between the networks is that spoofed packets can be constructed that can affect the control network. That's what we were doing, okay? Spoofed packets, potentially permitting covert data to be tunneled in a loud protocol. That's exactly what we were doing. For example, if HTTP packets are allowed through the firewall, then a Trojan horse software accidentally introduced on an HMI or control network laptop could be controlled by a remote entity and send data such as captured passwords to the entity disguised as legitimate traffic. That's slightly more sophisticated and a little more complex and a little more expensive. So as we go through each of these iterations, they get a little more complex, they get a little more secure, and they get a little more expensive. So a slightly more sophisticated design shown next is the use of a router firewall combination. This router sits in front of the firewall and offers basic packet filtering services, while the firewall handles the more complex issues, either being stateful inspection or proxy techniques, right? This type of design is very popular in internet-facing firewalls because it allows the faster router to handle the bulk of the incoming packets, especially in the case of a DOS attack, and reduces the load on the firewall. It also offers an improved defense in depth because there's two different devices an adversary must bypass. And here's that configuration, right? So the outside world here, and we have a router and a firewall, okay, between the control network and the corporate network. Here's our data historian here. A significant improvement, once again, getting a little more complex, a little more expensive, right, is the use of firewalls with the ability to establish a DMZ between the corporate and control networks. Each DMZ holds one or more critical components, such as a data historian, a wireless access point, or remote and third-party access system. You know, one of the things that we really haven't discussed, and we'll talk about it a little bit tomorrow, is that because these systems often cover large amounts of territory, right, they have to have wireless communication, right? So, you know, when we're talking about a system that covers miles, kilometers, tens of kilometers, hundreds of kilometers, miles, yeah, you just can't wire. You can't send wire across them. So most of them have some kind of wireless communication. right? And this is a real vulnerability in these systems. Locally, it's a vulnerability, okay? Or remote or third-party access systems. In effect, the use of a DMZ-capable firewall allows the creation of an intermediate network. Creating a DMZ requires that the firewall offers 3 or more interfaces rather than typical public and private interfaces. One of the interfaces is connected to corporate network, the second to the control network, and the remaining interfaces to the shared or insecure devices such as the data historian server or wireless access points on the DMZ. Let's take a look at that configuration. Once again, what we've done is that we've created, notice there's 3 interfaces on the firewall, right? We have a firewall and a router, okay, between us and the outside world. That goes without saying. And then we have an internal firewall with 3 interfaces, right? One to the corporate network, one to the DMZ. We've put the data server and the data historian into the DMZ, and then all of the control network, okay, the SCADA network goes into the a segregated network. All right, lots of text here, okay? We're going to take it to another level here. By placing corporate accessible components in the DMZ, no direct communication paths are required from the corporate network to the control network. Each path effectively ends in the DMZ. Most firewalls can allow for multiple DMZs and can specify what type of traffic can be forwarded between zones. As figure 5.3 shows, which is next, the firewall can block arbitrary packets from the corporate network from entering the control network and can regulate traffic from the other network zones, including the control network. With well-planned rule sets, a clear separation can be maintained from the control network and other networks, with little or no traffic passing directly between the corporate and control networks. If patch management server, okay, or an antivirus server, or other security server is to be used on the control network, it should be located directly on the DMZ. Both functions should reside on a single server. Having patch management and antivirus management dedicated to the control network allows for the controlled and secure updates that can be tailored for the unique needs of the ICS environment. It may also be helpful if the antivirus product chosen for the ICS is not the same as the antivirus product used for the corporate network. Okay, good idea, right? You know, one of the things that also that, you know, the challenge here is that a lot of your standard antivirus isn't going to work within a SCADA ICS environment, right? It's designed to run on the corporate network. And a lot of the attacks are not be recognized by standard ICS, by standard antivirus. So a lot of the things that, you know, we take for granted in our traditional IT environment is simply, in many cases, not available to us in a SCADA ICS environment. More and more, we're beginning to see, you know, manufacturers, developers put together products for the SCADA ICS environment, but they're still far from an adequate number of companies, and most of your standard off-the-shelf products just simply aren't going to do you any good in a SCADA ICS environment. It may also be helpful if the antivirus chosen is not the same, okay, so they can pick up different antivirus. One of the truisms of antivirus is that not all antivirus is the same. I think we talked about this earlier. You know, antivirus software, if you take known attacks and you run them against different antivirus software, you get different results. So it often, you know, people will come to me and say, hey, you know, I ran my antivirus and still I got attacked. What happened? How can that be, right? Well, antivirus is not all the same. They have different techniques. You know, the simplest technique is simply doing signature analysis, and in that case, that's certainly not going to do anything for a signature analysis. It's not going to do anything for a 0 day, right? And even then, signature analysis can be evaded, right? OptFX says that's quite presumptuous, and any interconnected networks are always vulnerable no matter the DMZ or other acronyms. That's certainly true. What we're doing, okay, and your statement is true, but what we're trying to do, as we always do in cybersecurity, okay, InfoSec, is to make it more difficult, all right? There's no such thing as a secure system. So you're saying that any interconnected networks are always vulnerable. Yes, that's a truism, right? No argument there. But all that we can really do is to make it more difficult for the attacker, right? You know, a determined attacker is almost always going to find, a determined attacker with the skills and resources is always going to find a way in. What we want to do is to at least slow them down and make it more difficult. And maybe by slowing them down, we detect it and are able to react to it, right? So yeah, your point is well taken. CJ says, shouldn't control network just be air gap from all networks? You know, ideally, CJ, that's the case, is that it'd be air gap from all the networks. The truth is that they're not, right? So in my experience, you know, there's very few that are air gapped, and usually those are the ones that require the highest level of security, right? And yeah, and OptFX's convenience, my friend, that's the key word, right? Is that if you air gap a system, right, what does that mean? That means that I have to have somebody on site 24/7, 365 days on site. And that's just not, that's not convenient or possible for a lot of situations. Okay. Yeah, it's simply not feasible. It's not convenient. You can't, people can't, you know, for instance, let's talk about the Iranian uranium enrichment facility. That was air gapped, right? And that's part of what made it so difficult, right? Part of what made it difficult. I mean, it made it difficult, but not impossible, right? But that meant that they had to have people in there, and it's a national security facility. So you know, you can always force your people to work 24/7, 365 days a year, or have somebody work that. But for most, you know, remember that most SCADA ICS environments are not national security environments. They're commercial environments. They are profit-making enterprises, right? That's one of the you're talking about, you know, a military operation, a nuclear facility, then, you know, then yes, 24/7, 365 days a year is can be done. Okay, because there's no profit motivation, right? But once you put it into a profit environment, a profit motivated environment, then it gets really expensive. Okay. Let's see, everyone, audio, you lost the audio. Okay. Yeah, and the audio apparently is back, but basically what I was saying is that we always have this tension, okay, between a profit-making entity and national security concerns. Okay, so if for instance, your job is to run security for a major financial institution or credit card company or an e-commerce site, right? There's probably not going to be major national security consequences, right? If you're running security for the electrical grid, right, or a refinery, those are, at least in the West, okay, those are private profit making entities and they are trying to minimize costs, okay? OptFX says, I'm having a major debate with a professor at Hopkins over this. I guess you're at Hopkins. I remember you told us you're doing a program at Hopkins, Johns Hopkins in Baltimore, major university in the US. So yes, this is an issue, right? This is one of the key issues. If all of these facilities were owned by the state, and the state stated that there'd be all offline, and you have 24 monitoring of, that would make things more secure. As we know, it's not totally secure, but it's more secure. But that's not the case. That's not the case in the West. Okay, and it's not even the case for that matter. I mean, Russia has some of these facilities that we're attacking are private. They were publicly owned. Okay, in the old days, 30 years ago, before the Soviet Union fell, and now they're privately owned, and therefore they have a profit motivation in them. OptFX's private entities are not only of private concern when these facilities affect masses, and that's exactly the point that I'm trying to make, is that they have national security concerns owned by private profit making entities, right? So how is this tension resolved, right? Well, there's many ways that you can go about this, and one of them is that the state steps in and mandates certain controls, right? That would be one of the ways. And at least in many countries in the West, and certainly in the United States, there is a lot of resistance to the state coming in and mandating certain things, right? There's a lot of resistance to that. Matter of fact, it'd be almost impossible to do, okay? At least in the US, right? Which is what I know best. Or you could put in regulations, okay, and say, you know, you guys should do these kinds of things, or the state can actually offer an incentive by paying for the security. And we've seen some of that take place, right? Where the state comes in and says, well, you know, it's really important that you be totally secure, so we will pay for your security. So maybe 10 years ago, I worked on a project from US Homeland Security to make the US railroad secure. So Homeland Security had determined, and this is a good determination, a valid determination, that the railroads had national security implications, right? And all of the railroads in the US, with the exception of the passenger rail in the US, is all private companies, right? So they said, look, it's really important that you guys be secure for national security purposes. So we will pay to improve your security. We will give you like grants. And so I was part of that effort, at least for one of the major railroads. And so that's the way it's still done in the West. Okay. Chris says, wasn't Osama going to do a terrorist? I don't know if that's true, Chris, but that certainly was the way the U.S. government interpreted it. So that may be true. Thereafter, I don't know that, but it was soon that U.S. Homeland Security, which is the agency that's in charge of security of the U.S., started giving out these monies to the railroads to make them more secure. They were really insecure. I mean, we started testing their systems. We were able to DOS their systems, you know, just without any problem whatsoever. So we could knock out all of their control systems by simple DOS attacks, and they would have no control over their own rail systems, right? All the rail systems now are digitally controlled, right? So we were able to DOS them, very simple, and that was one of the first things we did to test their security. OptFX says, Western governments remain quite inept at actually making any meaningful impact here. Well, that's kind of a judgment call there. But let's just say that in 2022, most of what we call SCADA and ICS systems in the West, okay, are very insecure. All right. And I'm kind of surprised that we haven't seen more attacks from the Russian hackers against the West. I was really expecting this, as you probably know if you read my tweets, right? I was expecting it. We've seen some, but they haven't been very successful. And a lot of people are saying that the Russian hackers are inept or not up to what we thought they were. And that may be true. And there may be other reasons other than ineptitude that we have to keep in mind that this still is a risk. And I'll give a little plug that next week on Wednesday, I'm speaking at a conference on cyber war and business risks on just this issue. I'm one of the keynote speakers there. And we're talking about, what does cyber war mean in a business environment? What are the risks to it? So Chris says they found some documents. Probably why they started security. That's probably true. Michael McBride says, or they fled, LOL. Bello says they didn't want this to escalate. Yeah, it may be that the Russians were afraid of the security of their own systems, because we've now clearly shown that they are not as that secure. We've been able to attack effectively many of the systems, and maybe they were afraid of our trying to escalate and take out, their electricity grid and their oil refineries and what have you. I don't know, but what we have seen is we've seen very little from the Russians attacking the U.S. And it may be that this is total speculation, but it may be that our continued attacks against the Russians, continued attacks from day one, have tied up their people in just trying to repel the attacks and not giving them the adequate time and energy to be able to return the attacks, right? Because we've seen a lot of attacks against the SCADA ICS systems before the war, right? We've seen a lot of them before the war. We've seen the Russians all over SCADA systems in Saudi Arabia, in the US, in Europe, right? And we haven't seen much since the war started. So, I don't really know why that is. I don't think it's incompetence, though, right? I think that it's always dangerous to assume that your opponent is incompetent. Okay, that's always something you should not do. OptFX says, CJ says, how can we listen to your keynote? It's limited to CIO, CEOs, CISOs. But if I get a copy of it, I'll make it available to all the subscribers on Hackers Arise. So I'm pretty sure they'll give me a copy of it, right? But they're charging to come in, and they're limiting it only to the C-level folks in corporations. That's not my decision. Okay, so I'm not the one who's cutting out. The people who are putting on the conference made that decision. They might be charging a lot of money for it too, which might also be one of the reasons. Let's see. So I will, if I can get a copy of it, I will put it in Dropbox or someplace for you guys. OptFX says, U.S. Cyber Command would like to think they have a handle on these issues, but I'm not sure I agree there. My opinion is clearly conjecture, but I believe it to be a reality. Yeah. Well, U.S. Cyber Command has done a lot during this war, and they've offered a lot of assistance to the Ukrainians in this regard. But that doesn't necessarily, you don't have to be part of the Ukraine-Russia war to be able to attack a third country, right? And so I am still not certain why we haven't seen those attacks, but we will probably find out, especially as Russia is now beginning to lose this war. That's my estimation. Okay, I think Russia is beginning to lose this war, and in part that's because of a lot of things and some very brave warriors in Ukraine, and it's also from a lot of the cyber attacks that as well. Right? So there's multiple reasons there, and I think everybody can be happy that there's that the war seems to have begun to turn against Russia. As the war turns against Russia, right? How does Putin react? Right? That's what we have to be worried about. Right? Is that how does he react? He gets more desperate. Right? And when you corner a rat, okay, that's when they can do their most vicious attacks. And we may have cornered a rat, and then you have to be very cautious. Or any wild animal, you corner them, and then rather than giving up, they simply then lash out in wild ways that are unpredictable. Okay. OptiFX says it's now a war of attrition. I'm not sure I agree with that. Is a war of attrition? A war of attrition is just one where see who kills the most people. I think that the Ukrainians have proven themselves to be more effective, and I think that the American weapons, okay, have been more effective than the Russian weapons. That's not a war of attrition, I don't think. I think there's really the things have turned, and it's going the Ukrainians' way. All right. Administrator says, if we speak about cyber, it's really a first cyber war we are watching taking part in. Administrator, I agree with you that it's maybe not the first. There's cyber wars going on all the time, but this is the first great cyber war. It's the first major cyber war in the history of the world, right? So I would agree with you on that. A couple, you guys are kind of taking up my keynote for Wednesday. This is what we're going to be talking about. Knapp says, I heard Russians are now leaving the country en masse as they're afraid of being called in military service. Yes, there's hundreds of thousands of men have left Russia, trying to leave because they don't want to be called up. And think about it, even if you agreed with the Russian war, Putin's war, the Russians are giving these men no training or little training and poor weapons. Do you want to go to the front line with a 40-year-old rusty weapon, okay, to fight against the Ukrainians who are fighting for their homeland, who are very motivated and have good weapons? Probably not. Even if you agreed with the principle of the war, he's basically sending these men out to be cannon fodder, right? Meadow says, do we have any materials you would suggest to become more familiar with ICS? You mean just how ICS works? Is that what the question is? Yeah, administrator says he means the scale. Yes, I agree that the scale of this cyber war is the greatest cyber war in the history of the world. But I can assure you that's not the last one, right? So this war is showing the world how important cyber war is, right? Because cyber war, you know what? I talk to people still, okay? We're what, 7 months into the war? And we're more than 7 months into this war. I talk to people who are following the war, right? Who are following the war, but don't know there's a cyber war going on. So you and I, we know that there's a cyber war going, but much of the rest of the world doesn't know there's a cyber war going on, right? Because the press isn't giving all that much attention to it. So they're not familiar, they don't know, okay? So OptiFX, reading some more of the comments as well. Russia is now being worn down and backed into a dangerous corner. I agree with that. Okay, they're being worn down and backed into a dangerous corner, and Putin is threatening to use nuclear weapons. You know, that's what happens when you corner an animal, right? Is they'll lash out in unpredictable and vicious ways. Nick says, there are options and kits available of hardware that you can buy to practice on ICS SCADA as well. Yeah, so there's a number of tools if you just want to find out how these systems work. There's on Hackers Arise, I've got a simulation of a Modbus slave, master and slave. There's some also on Hackers Arise. There's a ladder lot. There's a number of things like OpenPLC, which is a PLC software with as well. So those are all resources that you can use if you want to become more intimately interested in how the systems work at the PLC level. All right. Let's continue on with our network segment. That was an interesting conversation. You guys have a lot of good ideas and good opinions. And this is a lot of what I'm going to be covering in this, it's called the CIO Net in Brussels, talking about the risk of business and in a cyber war environment, right? Mello says, yeah, in any books or, for instance, PLC logic or control system architecture, sorry you broke up when you're saying some of that stuff, okay. Administrator says, I know there are several media reports, materials preparing a cyber war topic in Ukraine. Even the Guardian journalist is searching for the sources here in Kyiv, so I hope more of it will be revealed. I hope so too. I mean, Guardian has been doing some of the best work in terms of cyber war, right? They've been one of the few major media outlets that's dedicated some time and energy to cyber war, but there's so many other media outlets who are really not covering it at all and really have no clue as to what's going on. And most of the public has no clue. Even the people who are following the war don't get any cyber war information, right? Anyways, let's go back to our network segregation. I told you I'm going to keep this under 3 hours. You can hear my voice is starting to give out. So I've talked a lot, and we're going to have to kind of close up this segment before the top of the hour. So we talked about patch management server, antivirus server. Then we're going to talk about the primary security risk in this type of architecture is that if a computer in the DMZ is compromised, then it can be used to launch an attack against the control network via application traffic permitted from the DMZ to the control network, right? This risk can be greatly reduced if a concerted effort is made to harden and actively patch the servers in DMZ, and if the firewall rule set permits only connections between the control network and the DMZ that are initiated by the control network devices. So it has to be initiated from the control network to the DMZ and not reversed. Other concerns with this architecture are the added complexity. That's oftentimes, okay, what's happening is that people simply won't do this because of the added complexity and cost, and the potential increased cost of firewalls with several ports. For more critical systems, however, the improved security should more than offset the disadvantages. Paired firewalls between corporate network and control network. A variation on the firewall with DMZ solution is to use a pair of firewalls positioned between the corporate and the ICS. Okay, this would be the most expensive and the most complex, but also the most secure way of handling the segregation. Common servers such as a data historian are situated between the firewalls in a DMZ-like network zone, sometimes referred to as a manufacturing execution system layer. As in the architecture described previously, the first firewall blocks the arbitrary packets from proceeding to the control network or the shared historians. The second firewall can prevent unwanted traffic from a compromised server from entering the control network and prevent control network traffic from impacting the shared servers. All right, so here's the more secure and more complex architecture. The key difference here is now we're using 2 firewalls. All right. And ideally, these two firewalls are coming from two different manufacturers. Why? Because the firewalls can also be compromised by the attacker, right? And not only can they be compromised, but sometimes it's you can bypass a firewall, so that if I'm inside the corporate network and I can bypass this firewall, I can bypass this firewall too if they're the same manufacturer, right? So, you know, the whole concept of defense in depth, right? We all know that. And that only applies if you have different types of devices at each level of depth, right? And these should be different manufacturers. Once again, adding the complexity of the system. If firewalls from two different manufacturers are used, then the solution may offer an advantage, okay, if they're from different manufacturers. It also allows the control group and the IT group to have clearly separated device responsibility because each can manage a firewall on its own if the decision is made within the organization to do so. The primary disadvantage of the two firewall architectures is the increased cost and management complexity. For environments with stringent security requirements or the need for clear management separation, this architecture has some strong advantages. Okay. All right. Just one more thing I want to do before we call it good for today. Let's go ahead and open up my Kali. And let's talk about the Kali must be here. Yeah, there it is. 2022. Not in the virtual machine. Let's open this up. Well, Administrator, I hope that you're keeping the people at the Guardian up to date. I've had a few media outlets contact me to discuss it. And surprisingly, some of these things that our discussions haven't made it into reports. So hopefully that we see more of that, because, you know, I have friends in the industry, friends in this industry that we're talking about right here who don't know about this, what's going on in the cyber war. All right. Well, yeah, I think that Guardian so far has been the best. And is Voltage, are you still here? Voltage has been getting coverage by IB Times. So we've seen some of the articles there. Let's see what we got here. A couple of comments here. For anyone interested, okay, this is from OptFX. Okay. The Irregular Warfare Combating Terrorism Center is hosting a panel beginning today at 5 p.m. on proxy warfare and its application to the Russian. Thank you. It's on YouTube. Likely to be non-technical and more policy focused than, and maybe interesting nonetheless. You know, the group that I'm speaking with in Brussels is going to be, you know, it's going to be semi-technical, right? It's mostly going to be policy. It's going to be business leaders and military leaders talking. So, administrator says, I think it'd be great to have you, OTW or Voltage, do the comments for media. I'd love to do it. Send them to me, and I'd be happy to talk to them about what's happening. So let's talk a little bit about IDSs. Okay. Let's look at an IDS like Snort, an open source. I think I got Snort on this system. I guess I don't. So let's go see if we can download it. Sudo apt install Snort. Unable to locate Snort. Let's do a sudo apt update. I'm happy to talk to any of the media about what's happening, and I'm sure Voltage is as well. hopefully we can get more coverage for what people are doing in the cyber war. Just give this a moment, see if we can't get it out of the, after updating our, if we can't get it, we can get it off their GitHub site. We find what the URL is for that. User says, what do you snort for? Snort is an IDS. Okay. I found somebody's got snort. Okay. Let's go ahead from GitHub. Let's go sudo git clone and HTTPS. Get this URL correct. And just copy and paste it. Okay. That should do. Unable to access, could not resolve host. Oh, it's because I forgot to put the GitHub in there. GitHub.com/ that should do it. Yeah, IDS is intrusion detection system. So what it does is that it's intended to simply detect attacks, right? There we've got it. Okay. So it's not going to block attacks. You can actually configure it to block attacks, but its intention is to alert you to attacks. It's an IDS. It's a intrusion detection, not prevention. All right. And so to run snort, it's going to be gotta spell it right. Just go snort. Okay. How about sudo snort? Still not. It did. Let me see if I've got it. Put it in a separate directory. Yeah, here it is right here. Let's go change to looks like I got a couple of them in here. I got 2.290 and 2. Which one is the most recent one? This one here. So I have it in here earlier, 2.920. Let's just go with that one. That one's the more current one. Either case, you can get them off GitHub. Okay. And then go ls-l. ls-l. The caps lock is on. Okay. Now we're going to have to build this whole thing. It's not already built. I was hoping to just. I thought I had one. It's already built. want to see if I have one. I think I have one on another system here. I think I have it right here on this one. Give me a second here to try this one out. I've already got it installed on this one rather than build it all. For those who aren't familiar, Snort is probably about the first IDS that was ever developed. It goes back to like 1998. And it started as an open source project. It's now owned by Cisco, so it's now built into a lot of the Cisco products. They bought it, I think 2014, I think somewhere around there, 2014 they bought. It was owned by a company right next to NSA in the Washington D.C. area, the Baltimore area, which is where OptFX is at right now. And let's see if I've got one here. Huh. Thought I had it on this system. Let's see if I can. Let's do sudo apt install. Some of the older repositories have Snort. Nope. Okay. Well, let's call it good for today. What I'll do is I'll go Snort overnight and we'll run it tomorrow. As you can tell, my voice is beginning to give out. Okay. Chris says, is Snort an IDS and Splunk an IPS? Okay, that's a good question. Okay, and we're going to talk a little bit tomorrow about Splunk. Splunk is not either of those. Splunk is actually a tool for gathering the machine data for analysis. Now, in essence, when you do gather that machine data, yeah, it's an SEIM or SIM. It can be used to be able to create alerts, okay, and it can actually be used to actually block, but it's not. Its primary functionality is to be able to gather machine data. Okay, so one of the problems of being able to manage the security of a system or a network is to be able to gather all of the log data, right? There's so much log data in so many different locations. So Splunk allows you to bring all of that together, right? And then be able to analyze that data in one place. Once you've got all that data in one place, you can then begin to put together some alerts on the system. And actually, it's kind of tedious to do it with Splunk. I wouldn't recommend it, but it can be done, okay, to use it to block traffic. And I've got some tutorials on Splunk on Hackers Arise. One of the problems, okay, if we're talking about Splunk, okay, is that Splunk isn't capable of dealing with SCADA ICS protocols, all right? And so generally, if you're going to use Splunk, to on your SCADA ICS environment, you need something that's going to translate the data. What Kepware does, they create a server that gathers the data from your SCADA ICS environment and essentially is able to talk to not all the SCADA. What they do is they use OPC. OPC is kind of like a lingua franca. It's a language that almost all of the devices can talk to, and then it translates that data for Splunk. So this ends up making the system a little more expensive, like $10,000 in that area for what's called a Kepware server that goes ahead and translates the data for your Splunk. So Splunk is a great tool. I love it. Okay, it's one of my favorites. But as it comes out of the box, it can't do SCADA ICS. You have to pair it with a company called Kepware. Let me go ahead and I'll pull up Kepware on the screen for you. Let's see if I've got a browser here, and I can go ahead and get you to show you what they've got. And I've got a tutorial on Hackers Arise on using Kepware for industrial automation and IoT. Okay, and this is there may be other companies doing the same thing now, but when I was trying to secure various environments, I found this one to be the most useful, but it does cost about $10,000. Okay. They have various, here's a demo download you can do. They have various servers for different environments, okay? So depending upon, so if you're working in oil and gas, it's a per year, Christopher, $10,000 per year. So they have servers for different environments, and you select the one that, here's education and support. Let's see what they have for us here. They also have try and buy. They have some free trials. Here's our Kepware product demos here. Explore Kepware. Optimizing factory automation for over 25 years. Let's look at the product suite. Let's learn more. What is a Kepware server? It's an industry's leading connectivity platform that provides a single source of industrial automation data to all your applications. Users can connect, manage, monitor, and control diverse automation devices and software applications through one intuitive user interface. KepServer EX leverages OPC. That's what I was referring to, okay? This is the automation industry standard for interoperability. So this is what, it's one of the things we talk about in the advanced class is OPC. It was originally developed by Microsoft. I think we talked a little bit about it in day one. It's kind of a language that allows for different communication protocols to communicate to each other, and this is what the KEP servers use. It's an IT-centric communication protocols such as SNMP, ODBC, and web servers to provide users with single source of industrial data. This is what your Splunk requires to operate in a SCADA ICS environment. All right. A couple questions there. Okay, CJ says, so this would run on a data historian? Not necessarily. All right, so basically what it allows you to do is to collect data on all of the devices in your SCADA environment. And so just like, so what Splunk does is Splunk goes out and you can tell it what devices. It can be any and all devices on your network, and it'll collect the machine data, okay, which is, it's a variety of machine data depending on what you want to collect, and brings it all into a single database, all right? But to be able to do that, to be able to bring it in a single database, you need the Kepware server, okay, to be able to translate it in a way, in a form that Splunk can use. So think of your SCADA environment. You have a Kepware server that collects all the machine data, and then the Kepware server translates it so that your Splunk can actually use it. Okay, so let's call it good for day 5, and tomorrow we'll look. I'll get the snort running for us, and see if I can get I might be able to get a Splunk set up for us as well. We can take a look at that as well. But there is tutorials on both of those on Hackers Arise, and tomorrow we'll also look at attacking HMIs. So Thank you all for coming, and we'll see you tomorrow. Sorry the class is so short. Yeah, thank you. I appreciate that. You can see my voice is getting better, but it's definitely not. It's already getting scratchy and sore. So I'm pretty sure I can do another 3 hours tomorrow. We can finish up all the securing of the SCADA ICS environment, which is distinctly different than a traditional IT environment. So we'll see you then. Have a good evening.